Hey guys, this is the review for your Spiral 3. We're going to start off with functions, domain, and range. And I'd like to remind you that I will often do problems that are a little bit more theoretical on your review, and then you'll see more concrete versions on the spiral itself. So for example, a function whose domain and range are both finite. Finite means that they don't go on forever. In other words, they don't go to infinity. Any function that does not go to infinity would do just fine. So for example, that would be a function whose domain and range are both finite. The domain goes from, I don't know, negative 6-ish to positive 8-ish, and the range goes from about negative 4 up to a little bit more than 4. Since the domain and range both have values that end that is why it's finite. To make it no longer a function, we could add points that repeat x values. So if I put like a point there or a point there, that no longer fulfills the vertical line test, and that would not be a function. Now I'm looking at a domain that's finite, but a range that is not. So a range that's infinite. That means somewhere on my graph I've got to go off the grid, going in both directions. Or potentially one direction. Doesn't really matter as long as I'm going off my graph in the y direction somewhere. I've got to go a little bit further here, and you might remember from Algebra 2 we had these things called asymptotes. And asymptotes kept us from going past a certain point horizontally. Because since my domain is finite, it means I have to stop. I can't go off the paper in those directions. Between there, this might look something like this. It doesn't really matter all that much. There are also some ways that you could do this without actually making a function. For example, if I wanted to, I could make some kind of a squiggle mess like this. That's fine. Or I could even make a single vertical line, and that would be a relation with an infinite range, but a single point for the domain. For the function section, here we're looking at some problems that are combining functions on tables and functions from points. So for f of g of 3, first thing I've got to do is find g of 3. G of 3, g is the lower graph, okay, so g of 3, 1, 2, 3, equals negative 1. Since I'm finding f of g of 3, I'm really finding f of negative 1. Okay, f of negative 1 is equal to, so I'm going to use the top graph, and negative 1 has a value of 0. G of f of 3, now I'm going to start from the inside. F of 3 has a height of 2. I'm going to plug that in, g of 2, and there's 2, has a height of negative 3. F minus g of 2. In other words, f of 2 minus g of 2. Well, f of 2 is 2. G of 2, so I'm finding g of 2 is negative 3. 2 minus negative 3 is 5. G of f of 0, work from the inside out. F of 0 is 2. Now I'm going to look at my next layer. So that's the g of f of, and f of 0 was 2. So f of 2, we already found out was 2. Nice. And now I need g of f of 2 is the same as g of 2. So g of 2, and that's equal to negative 3. Looking at our next one, we've got 2 times f over g of 1 plus 3. So let's find f of 1 over g of 1 first. F of 1 is going to be 2. That keeps coming up, huh? G of 1 is 3. And we're going to multiply that times 2. So 2 times 1/3, and then we're going to add 3 to that. So that'd be 3 2/3. If you wanted to leave that as a improper fraction, that'd be 11/3. 2f of 3 minus 3g of 2. Okay, 2f of 3 is going to be 2 minus 3, and g of 2 is going to be -3. 4 plus 9 is 13. Now we're on to transformations. I'm going to do the x stuff first. So I'm going to go -9 is equal to the inside. That's x plus 1. That new point is going to be 10, or -10 rather. My other point, 5 is equal to x plus 1. That means my new x value is going to be 4. Let's look at my y values. I'm going to multiply the y times -2 and then subtract 3. My first one would be 3 times -2, -6, minus 3 is -9. And my second one would be 5 times -2, minus 3, which would be -13. So you might say these are being moved left 1, the y's are multiplied by -2 and then being moved down 3. Unfortunately, neither of these will show up so well on our graph. One of these days I might give you something that actually graphs on there easily. For our next one, we do the same thing. I might add a third point here of -2, -3, just because it's nice to have the vertex, and go piece by piece. So first point, -3, -2. I'm going to do the x first. -3 is equal to -2x. X is equal to 3 over 2. Now the y, I've got -2, nothing being multiplied, plus 2 for the end of this is equal to 0. My new point would be 3 over 2, 0. So that would be here. Second point, let's take a look at that vertex. So we're looking at -2, -3. I'll do the x first. -2 is equal to -2x. That means that x equals 1. Now I'll do the y, -3. There's no multiple, so just plus 2 equals -1. My point is +1, -1. And finally, we've got a third point, 0, 1. I'll do the x first. 0 is equal to -2x. That means that x equals 0. And we'll look at the y. The y is going to be 1 plus 2, which is 3. So 0, 3 would be that point. Let's plot those points. So 0, 3. My vertex is at 1, -1. And I've got a third point at 3 over 2, 0, which is there. So if I connect those, it's going to look something like this. A skinnier parabola that has shifted and looks like it's flipped around some. And then for the last part of this, we've got some trigonometry. I'm going to zoom into these so we can see what's going on. First triangle, I've got to solve for the entire triangle, and I'm given two sides, a 7 and an 8. First thing I might do is solve for my third side, which is side BA. That's the hypotenuse, so I could Pythagorize it. 7 squared plus 8 squared is going to be BA, or C squared. And doing that, 49 and 64 is going to be 113. And that's equal to C squared. Square root both sides. C is equal to the square root of 113. Now we need to get some angles. So I'm going to arbitrarily choose A. And I don't know, I like sine best for some reason, so I'll choose sine. Sine of angle A is equal to 7 divided by the square root of 113. I know that to get an angle, I've got to use an inverse trig thing. So sine inverse to both sides, and I get sine inverse of the square root of 113 is going to be A. When I evaluate that, I get A is equal to 41.19 degrees. I can use the fact that the three angles of a triangle add up to 180 to figure out angle B, and do something like angle B, or the measure of angle B, is equal to 90 for that right angle, plus 41.19, and that's got to be subtracted from 180. I did this in kind of a backwards way, but the gist of it is that if I do 90 minus 41.19, I get that angle B is 48.81. 6B should be pretty similar. Here I'm given some more angle information, but I have less in terms of side information. Again, realizing these have to add up to 180, I might quickly do that angle A is 40.5, and then I can use some trig to figure out the other stuff around me. I'm going to go for that side first, and then I might use the Pythagorean theorem to get the last piece of this. So I've got angle B. I know this is opposite angle B. Here's my hypotenuse. This is adjacent. Maybe use some tangent to get that opposite and adjacent going on. So tangent of 49.5 is equal to the opposite over 10. And tangent of 49.5 is going to be 1.17. 1.17 is equal to opposite over 10. Multiply both sides by 10. And I get 11.7 is equal to this side over here. I could, from this point, Pythagorize. So let's call that side B, or side AC. And I could Pythagorize and get 11.7 squared plus 10 squared is equal to C squared. So 11.7 squared plus 10 squared, and that's equal to 236.89. Square root both sides, and I arrive at an answer of 15.39, or somewhere close to that. Problem 7 is similarly set up, but here we're giving you word problems. We've got Jimmy who's hiding in a tree, and Andre who sees him. Andre is standing 50 feet away from the tree. Okay, so there's Andre, here's a tree, and the distance between them is 50 feet. The angle of elevation to Jimmy is 20 degrees. We're going to make the assumption that Andre is looking from the ground. Makes the problem a little bit more digestible. And he's got to, we've got Andrew instead of Andre. Let's cross that out. So where does Andre have to position a 24-foot ladder? That's talking about this distance. So this is the ladder to reach the top of the tree. So where Jimmy is going to be. This is kind of a tough question. I think there are several parts going on here. Because there seems like there's more to this problem than meets the eye. I'm going to save this part of the question for a minute and first ask, how tall is the tree? Okay, well, now I know we've got an angle. This is going to be an opposite side, and I've got an adjacent side. So I've got an opposite and adjacent. I could say that tangent of 20 is equal to question mark, that's my opposite side, over 50. I can multiply both sides by 50. And 50 times the tangent of 20 degrees is going to be 18.1985 feet. That's really what I was looking for you figuring out in this problem. The second part of this begins with this ladder. So now I know the tree is going to be 18.1985. The ladder is 24. I need to figure out how far away from the base of the tree the ladder should be placed. Since this is a right angle, we're really looking at this in terms of Pythagorean theorem. So 24 squared minus 18.1985 squared is equal to whatever that is squared. So 24 squared minus 19.198 squared, square root of both sides, I get 14.40 feet. So Andre would have to put that ladder 14.4 feet away from the base of the tree. Continuing ever onward, we're looking for side BC. This appears to be a non-right triangle, especially considering that my third side is going to be 89 degrees. And I've got to figure out if I want to use law of sines or law of cosines. Given that I know some opposite information, law of sines is a good bet. So I'm going to write law of sines. Okay, so I'm looking for BC. That's over here. So I'm going to use that set of information also. Let's set this up. We've got sine of 89 over 32 is equal to sine of 30 over 61. And by 61, I mean x. That's my unknown. I don't know why I just put the angle in there. I see that error all the time, and I don't want to incur. So if I do sine of 89 divided by 32, I get 0.0312, and that's equal to sine of 30 is 0.5 over x. Going to multiply both sides by x. I've got 0.0312x is equal to 0.5. Divide by that delightful decimal, 0.0312, and I get 0.5 divided by 0.0312. That unknown is equal to 16.03 units, which makes sense with a hypotenuse of 32. My last problem. If I take a look at my pairs, this time I don't have any matched pairs. And if I don't have any matched pairs, law of cosines is probably a good bet. Okay, so law of cosines, so I'm trying to find side AB, otherwise known as side C. Law of cosines is going to be c squared is equal to a squared, a is 25, plus b squared, b is 29, minus, I'm going to slide this over a little bit so we can see, 2 times A, 25, times B, 29, times cosine of 130 degrees. When it's set up like this, I can literally just do this all out. I could quite possibly write this as 25 squared plus 29 squared minus 2 times 25 times 29 cosine 130, close parentheses. Press enter, and I get 2398.04 is equal to c squared. One of the nice things about law of cosines is you can quite literally type things in and press enter and get some kind of a value. Square rooting, I get c is equal to 48.96, and based on that being the biggest side, that makes sense. That's a wrap.